Of the day, everyone. Today I'm going to do my research paper with the help of the Stata 16. Okay, this video is includes the two parts, part 1 and part 2. This is the first part of the video. In this video I will show you how to analyze the secondary data with the help of this data and interpret this data. Okay, in order to analyze the data, first of all we need this data. We should open this data and we need the do file. That's the file of the comments, and the detail file, the information file. Okay, here I have the detail file. Okay, I should open this detail file here. Okay, it's opened here, and I have I have two types of variables here. I have two types of the variables here. For the first one is the sales, monthly sales revenue in $1,000, and the second one is advertisement, expenditure on advertising in $1,000. Okay, and we'll analyze in this the research. We'll analyze how advertisement affects to the sale of that company. Okay, the next we should choose the let's say effectiveness here. Okay, we'll analyze the effectiveness of the advertising on sale, and we should open the do file as well here. We should open why do we need the do file? We have the comments here, and we'll use these comments. The first comment is BR. Okay, here we can see that secondary data. Okay. Let's go on. The next one is a sum. Let's write this with sdoc. Why we should write it? Because we'll get the data in the doc format. Okay. Here there's a sum of the summarize of the research. Here it's given the information. Okay, the observation of the sales and the advertising is 75 observation. Okay, mean score was $77.3 thousand, and the mean score in advertising is $1.8 thousand. Okay, here is the standard deviation and the mean score and the maximum score. Okay, you should click the my file doc. Here when you click it, here it's descriptive statistics. This information is the same with the statistics. Okay, you should copy it. Okay, after that we should open our research paper, and as we know, in the research paper there is a results section. Yep, here is a results section. After methodology we have the results section, and in the results section we'll interpret our results. Okay, here we should put our result. Okay, here it's the same thing. Okay, I should delete this one. I did it beforehand. Okay, here is a descriptive statistics. I should write the table 1. Okay, descriptive statistics shouldn't be bold. Okay, and we should interpret it. For example, the given table 1 summarizes the information about the research. The number of the observation is 75, and the minimum and the maximum amount of the sales are 62.4 and the $91.2 thousand respectively, while the average price is $77 thousand. Okay, the amount of the expenditure on advertising is between 0.5 and $3.1 thousand. The average amount of the expense spent on advertising is $1.84 thousand. We should interpret our table like this. Okay, because here is the detailed information. Here it's given the information about observation on the sales and advertising, spending, and a mean score, standard deviation, and maximum score. Okay, let's go on. Where is our next? Okay, we should close it. What is our next comment? It is two-way scatter. Okay, two-way scatter. One of them. Before that, we need the scatter plot. Okay, we should see our results in scatter plot. How the two variables are matching each other. How the dependent variable. Okay, here how the dependent variable has the effect in the independent variable. Okay, we got this data and we should put it in the scatter here. Okay, in our research paper. Okay, here I put it in the scatter plot. In the scatter plot, it's given that we use the scatter plot to find the relationship between dependent and independent variables. Here it's independent variables. We found that there is a little relationship between the monthly sales revenue and the expenditure on events. Okay, thank you. We got this the number. And why we need the two-way scatter L lift comment? Okay, here we can see amazing result of this comment. Okay, we can get the amazing scatter plot with the fitted value that line. Okay, fitted value line. This line shows how the two variables has any how can I say that relationship or not. Okay, here it's the positive relationship because it's increasing while the expenditure on advertising is increasing. That monthly sales revenue also increasing in $1,000. Yep, we should copy it and we should put it in our research paper. Okay, here we put it. Okay, I put it here, and we should write the scatter plot with fitted value, and here we should write the description. Let's make it 3 point. Okay, and I should delete these informations. Okay, here it's written the fitted values, and we interpreted our data here. Okay, let's go on. What is our next result? And you know, we have the different type of the tests in order to testify how the information given here is statistically proven or that statistically significant. Okay, here it's written that pure Pearson's test. Okay, in the Pearson's test we'll analyze it. Let's see that we will analyze how the information is. I should write as doc, it would be better. Okay, because I can get this information in doc file. Okay, in the Pearson correlation coefficient test, we can see that the relationship between two variables. Okay, how it's related that the sale advertising rate affects the sale only 22%. Okay, and it is the p-value probability p-value is 0.055, which means that's not significant enough, because whenever it's the p-value is less than 0.05, that we can consider this information as a reliable information. Okay, and I should open it, and I should here and I have already interpreted these data variables. Okay, here, and this information. Okay, Pearson pairwise correlation coefficient. Okay, the advertising affects only 22% of that to the sales. Okay, after that, what kind of test do we have? Actually, we have. Okay, after that we have this Spearman test. Okay, in the Spearman test, that's also one of the amazing statistical tests, and that's kind of same thing. And here it's written the number of observations, Spearman sales and advertising. That comment was like this, and the number of observation was 75, and the Spearman's RHO, that means the correlation coefficient between two variables is 23%. Okay, and the probability is 0.04, which means that statistically proven number. Okay, and we will copy it here. Okay, and here that Spearman test, we can analyze that. Here I have written that p-value is smaller than 0.05, which is statistically normal test. Okay, let's go on. What kind of variable? We have testified these two ways, and we should check it with the histograms, how normally distributed our data is. Okay, the first of all, we have the data with the sales. Yep, and let's check it. Oh, amazing! Here we can get the amazing result. and we should put it here. I put it here, and in the third histogram, we investigated that whether the given data is normally distributed or not by using histogram. Okay, it's revealed that the data is normally distributed in both histograms. We checked it with both histograms, and the same data with the sales, monthly sales revenue, and the expenditure and advertising. Okay, and another one is that FBox. FBox, here I use it FBox test. Okay, I should put it here. FBox with a sale. Okay, here the copy, and we should put it here, and we can interpret it that we found that 75%, this blue side, that means the 75% of the monthly sales revenue is between $73,000 and $82,000 with a median of $77,000, while another monthly sales revenue is above $62,000 and below $91,000. The same interpreting style goes with the advertising expenditure.